In this video, we're going to be looking at an example of finding a limit of a vector-valued function. So we're being asked to find the limit as t approaches 1 of t squared minus t over t minus 1 times I plus root t plus 8 times j plus sine of pi t over log t times k. So the way we're going to evaluate the limit of this vector-valued function is by taking the limit of each of its component functions and seeing if all three of them exist. If they do, then the limit exists, the vector as a vector where those values are the components of the vector. So let's look at the first component function. We want the limit as t approaches 1 of t squared minus t over t minus 1. We note that we can factor a t out of the numerator, so we're left with a t times t minus 1 all over t minus 1. We can cancel the t minus 1s because the limit as t approaches 1. We don't try to plug in 1 there for t yet. And we just get the limit as t approaches 1 of t, or we get 1. For the second one, t plus 8 has absolutely no issues with plugging a 1 in for under the square root, so we can just evaluate that limit by a direct substitution and get 3. For the third one, we'll use L'Hopital's rule. Since we would plug in 1 for t, we get 0 over 0. Derivative of the top is pi cosine pi t. Derivative of the bottom is 1 over t. Now we can plug in 1 without any issues. We get a 1 in the denominator. We get a negative pi in the numerator, so the limit's just negative pi. Therefore, the limit of our vector-valued function in this case is the vector I plus 3j minus pi k.